Find the derivative of this function from the first principle. So before I solve this question, let's look at the proof of sum rule, derivative of sum, so that we'll know how we'll solve this. Okay. Okay, we ask prove that if h of x is the sum of fx and gx. So we're going to use the first principle to solve this. So if we have h of x to be equal to f of x plus g of x, so as we know that if x is changing, so if we have x plus h, it will always change. So once it's changing in the left, it will change in the right. Remember, our main aim is that if f prime of x using the first principle is always that the derivative of a function is always the limit of h tends to 0 of f of x plus h minus f of x divided by h. So we need to prove this. So as we are from here, we've gotten this. So in proving from the first principle, we have 4 stages. The first one is to get the change, x plus h, that's the change. Secondly, we'll subtract the original from the change. Third, we'll divide by h or the x, depending on the one you are using. I'm using h. And finally, we'll find the limit. So we've done the first stage. So the second stage is to subtract the original function from this. So we have f of x plus h plus g of x plus h minus f of x plus g of x. So, and here we can bring this to this side. So I've opened the bracket, that's minus f of x minus g of x, but I now group it, the ones with f, the function f and function g. So the next step is to divide by h. So if we divide both sides by h, we'll have f of x plus h minus f of x divided by h plus g of x plus h minus g of x divided by h. So we're still correct. That's the third step. The last step is now the limit. So we'll get the limit of h tends to, as it tends to 0 of h of x plus h minus h of x over h. So the same thing, limit of h tends to 0 of everything plus that, sorry, over h. And we know that the limit of sum is the sum of their limits, so we'll get individually. That's for this over h. And for the second one, tends to 0 of g of x plus h minus g of x over h. So what do you have to say? We've arrived at the answer. Yes, because on the left hand side we have h prime x if you look at this is the derivative. So this is h prime x, while on the right hand side this is f prime x plus this g prime x. So prove that. So that's from the first principle. Okay, as we can see, we have that f of x is 8x minus 3 over 5x squared. X will also change. So if x is changing in left hand side, it will change on right hand side. So that's it. Okay, let me write. If you could remember that the derivative of anything is the limit of h tends to 0 of that function, the change, minus the original function over h. So that's how we solve. In solving using first principle, we have 4 steps. You have to find the change, subtract the original function from the change, divide by h, and finally find the limit. So we've done the first part, we've done this. So the second part is to subtract the original function, so which is 8 times x plus h minus 3 over 5 times x 1 over x plus h all squared minus 8x minus 3 over 5x squared. So which is equal to, we'll factor, this comes here, so we'll write 8x plus h minus 8x. So that I've moved this to this side. Why this minus times minus is plus, so I have 3 over 5. I factored 3 over 5. See 3 over 5, see 3 over 5. So I have 1 over x squared minus 1 over x plus h all squared. I just factored. I factored this to this. I'm looking at this. So why this has 3 over 5? That's minus times minus is plus 3 over 5 x squared. I factored it. So we see that we can subtract this. We are left with 8h plus 3 over 5 of LCM is x times x plus h all squared. Do you get? This is like x squared times x plus h all squared. The LCM is this, while this is x plus h all squared minus x squared. Let's move to the next line. Okay, so we can see that this is difference of 2 squared. So let's repeat this. Is x times x plus h all squared. So difference of 2 squared, this plus this is 2x plus h times this minus this is h. So the next step is to divide by h. So we'll divide both sides by h. As you can see, there is h here and there is h, so we are left with 8 plus 3 over 5 2x plus h times x plus h all squared. So the last step, which is the limit of h tends to 0 of f of x plus h minus fx over h, which is the same as the limit of h tends to 0 of 8 plus 3 over 5 times 2x plus h over x times x plus h all squared. So as you can see, this is now f prime. That's our f prime x. So which is equal to, we'll substitute h as 0 here. So 0 here, we'll have 8 plus 0, so we have 3 over 5 times 2x over 0 here. S times x squared plus times x squared, that's x squared all squared is s raised to the power 4. So which is 8 plus 3 over 5 2 over x cube. That's x is here. So our answer, therefore the derivative is 8 plus 3 times 2 is 6, that's 6 over 5 x raised to the power 3. So that's the derivative from the first principle. So that proof help us to, because if not for the proof, we'll make this mistake by bringing these two together, like their LCM. We'll try to get there, it will be very tedious to solve. So that's it.